My dear students, in this lecture we shall start a new chapter, that is on principles of physical similarity and dimensional analysis. This is the field developed by mathematicians which helps us in many ways. Like you consider a situation where we do not have the relationship among the variables involved in any physical phenomena. Like suppose we have a room in which a fan is placed, the function of the fan is to impart velocity to air. Now, this physical phenomena may be function of viscosity of the air, density of the air, RPM of the blades, number of blades, angle of the blades, etc., etc. Now, if we want to know that if this fan is rotating at a corresponding RPM, let us say 500 RPM, then what will be the velocity at different points in the room. Now, if we do not have any law which relates these variables, then we can't develop the equations, we can't solve it, and we can't give answer to this question. Now, what is the way out to solve this problem? Another way is to do the experiment, right. For doing the experimentation, when large number of variables are involved, we have to conduct large number of experiments. So, experimentation also becomes very complicated and costly affair. So, how can we reduce the number of variables involved in any physical phenomena? There is a way out, that is known as dimensional analysis. With the help of dimensional analysis, we convert these independent variables into some independent dimensionless terms. Right. In this way, we reduce the number of independent variables involved in any physical phenomena, and its experimentation becomes easy. Right. This is one way where dimensional analysis helps us in reducing the cost and efforts required for doing the experimentation where it is necessary. Whatever theory we have studied in the fluid mechanics so far, you might have realized by now that those theories are having their own limitations, either in terms of solving the equation, because whenever we want to solve a complicated equation, it is not possible. So, we have to make it simple by reducing some terms which are not important or which are less efficient or less value in that particular equation. Because of that, the analysis we do is much more simple, but we may not rely 100% on the results, because this may be having some kind of inaccuracy. So, whatever design we do with the help of this analytical approach needs to be tested with the help of some kind of experiment. And if we want to conduct experiment on actual size of the product, like if we want to design an aeroplane or ship or submarine or dam or spillway, it is not possible to conduct experiment on actual prototype. So, there is a need to develop a model on generally a smaller scale and conduct the experiment on same fluid or sometime on other fluid also, and find out its performance and try to find out that how will our actual prototype will perform in actual condition. So, for that we have principles of physical similarity. So, this chapter or knowledge which is available in this chapter of principles of physical similarity and dimensional analysis, in some book it is written as dimensional analysis and model testing, helps us in developing some kind of functional relationship among the variables involved in physical phenomena, or reduce the number of independent variables involved in physical phenomena. With the help of this approach, the experimentation becomes easy and its interpretation also becomes easy. And sometime we need to develop a model based on some physical similarity condition to conduct the experiment and try to find out how the actual prototype will perform in actual practice. And sometime we also need to do the experimentation for design purpose also. Suppose we want we are not able to design a component of aeroplane or ship or submarine with the help of analytical approach, then what is the way out? Way out is to conduct experiment, find out how it is working, right, and then try to find out how it will work when we will have prototype of same size, right. So, these are the possible areas where the knowledge of this chapter is essential, and we all know that whenever we develop product like aeroplane, ship, submarine, we have to use both approaches. First we develop the product with the help of analytical approach, then we conduct the experiment on a smaller scale and try to find out its performance, right. So, this is the way we develop product. It is not that just with the help of analytical approach solve the equation and get the dimension, etc., get the power required to propel aeroplane, ship, etc., and just fit it and go in actual condition. We conduct the experiment on a smaller scale, try to find out its performance, try to find out that how different variables are affecting the performance, and try to find out that how the actual prototype will perform in actual condition.